Welcome. Today we'll explore inverse trigonometric functions, specifically focusing on inverse sine, or arcsine. What does it mean to take the inverse sine of a number? Let's start by reviewing the regular sine function. Here's our unit circle. The sine of an angle theta is the y-coordinate of the point where the angle's terminal side intersects the unit circle. For example, when we trace a 30-degree angle, the y-coordinate of this point is the sine of 30 degrees. Now, the inverse sine function does the opposite. Instead of giving an angle and finding the y-coordinate, we start with a y-coordinate and find the angle. The sine function can only output values between -1 and +1, so these are the only values we can input into inverse sine. Let's solve sin superscript 1, 1. We're looking for the angle whose sine equals 1. On the unit circle, a y-coordinate of 1 occurs at 90 degrees, or pi over 2 radians. This is because at 90 degrees, we're at the very top of the unit circle, where the y-coordinate reaches its maximum value of 1. Therefore, the inverse sine of 1 equals 90 degrees, or pi over 2 radians. We can verify this. The sine of 90 degrees is indeed 1. Note that while there are other angles whose sine equals 1, we always use the angle in the interval from -90 to +90 degrees. This is called the principal value. To summarize, the inverse sine function finds the angle when given the sine value. For sin superscript 1, 1, we found the angle whose sine equals 1, which is 90 degrees, or pi over 2 radians. Remember that inverse sine only accepts inputs between -1 and 1, and always gives answers between -90 and +90 degrees.